Hi everyone, today we are going to see the calculation part of air wedge experiment. The aim of the experiment is to determine or to find the thickness of a thin wire. A specimen wire will be provided. We are going to find the thickness of the thin wire, even the diameter of the thin wire. The formula to be used is the thickness of the thin wire T can be determined using this formula. Lambda L divided by 2 beta. The unit is meters. Thickness measured in meters. The expansion of the symbols to be written along with the relevant units. Lambda. Wavelength of the given source. The source provided will be sodium vapor lamp. The unit is meters. L is the distance between the edge of contact and the specimen wire. The position of the specimen wire in meters. That is the length between, this is a glass plate and this is the tied end or the edge of contact. Here I can draw a line. It is called as the edge of contact and this is the specimen wire. So in between these two we call this as L. The length between the edge of contact and the specimen wire. So it is taken as L here. And the beta refers to fringe width. Here number of interference fringes will be seen. The width of one fringe is given here. So beta is width of one fringe or fringe width in meters. Now this is the diagram and we are moving on to the calculation part. For that, reading is important. There are two tabular columns here. One is for finding beta. Another one is for finding L value because lambda value will be given. The value of lambda is 5893 angstrom unit. That is 5893 into 10 power minus 10 meters. We are going to find beta and L only. Now let us consider these are the sample readings. In traveling microscope we have taken this reading. Let N be any one fringe. It is considered the cross wire, the vertical cross wire is made to coincide with this nth fringe. Let this also be taken as nth fringe. Any one can be considered as nth fringe and the MSR and VSC of the traveling microscope is taken. And then here we have considered it as this is n plus 1, n plus 2 and this is n plus 3. Using the side screw provided in the traveling microscope, we can make the vertical cross wire to move over the interference fringes. At n plus 3, we are going to find again the MSR, the main scale reading and vernier scale coincidence for n plus 3. And then continuously next 3, that is n plus 4, n plus 5, n plus 6. The reading is taken. Similar way, continuously starting from any one fringe which is considered as n, for every 3 fringes, it should be in any one direction. Either it should be in this direction or even we can consider to count this in this direction also. Either n n plus 1, n plus 2, n plus 3, or here n plus 1, n plus 2, n plus 3. Any one direction throughout the experiment. These are the sample readings. In your calculator, this is MSR and VSE. The least count of the traveling microscope is 0.001 centimeter. So here the formula to find the total reading TR is MSR plus within bracket VSE into LC. So what is your MSR here? As per the sample reading, it is 8.60 plus and bracket VSE is 8. So 8 into this is MSR plus within bracket VSE into LC, close the bracket. Least count is 0.001, close the bracket, is equal to, your calculator will display this answer, 8.608. In the same way, we are going to do the calculation for the another values also. 556 and it is 8.504, 8.455 and 8.407, 8.359, 8.311. Let me do it again. 8.30 is MSR, VSE is 11 into 0.1, 0.001. So 8.30 plus 0.011. In your calculator, if you use it, you will get a direct answer, 8.311. Just one stretch will give you the answer here. Then look at the next column here, width of 3 fringes. That is, this is the first nth fringe. Let us consider this may be the nth fringe. And this is n plus 1, n plus 2, n plus 3. So width of 3 fringes we need to find. This is n and this is n plus 3. So the reading of n minus n plus 3 or the reading of n plus 3 minus n, it depends on what is the reading. Look at the reading here. It is in the decreasing order. So we can go with n minus n plus 3. That is, this minus this will give you 3. We are not going to take n minus n plus 3. Thereby, ma'am, I get minus 3. This is not the point here. That is, the n get cancelled off. You are finding only the difference of the 3 fringes. That is width of 3 fringes. That is continuously. The difference will give you the width of 3 fringes. Same way, it should be done in the total reading also. 8.608 minus 8.556. If it is supposingly in the increasing order. For example, 8.30 is here, let us assume. And if 8.35 is here, if it is in the increasing order, then n plus 3, this minus this should have been done in the calculator. N plus 3 minus n, you will get width of 3 fringes. So whatever may be the case, the difference between the two readings, adjacent readings, should be taken. So now as per this sample reading, it is higher minus the lowest. Here that is lower reading amongst the two. 8.608 minus 8.556. So I am subtracting here 8 minus 6. I get 2. I am leaving these two again. And then 10 minus 5. I get 5. 5 is 0. So it is 0.052. Similar way, this minus this. 6 minus 4, 2, 5. And then I get 0. And then this minus this. I'm going for 14. That is, or I can use the calculator here. 8.504 minus 8.455. Your calculator will help you. So I got 0.049. Similarly, 8.455 minus 8.407. I got 0.048. Similar way, 8.407 minus 8.359. This minus this will give you 0.04. I am using the calculator here. Then 8.359 minus 8.311. I got 0.048. That's it. 7 readings. The difference will be 6. Here, the next column is width of one fringe. That is, width of 3 fringes we have taken. Now, the width of one fringe is the difference of these two by 3. Therefore, width of 3 fringes is 0.052. Width of one fringe will be 0.052 divided by 3 will give you width of one fringe. So I will be getting 0.052 divided by 3. I got 0.0173. Here also the same way, 0.0173. Next is 0.049 divided by 3 will give you this value, 0.0163. Then 0.048 divided by 3, I got 0.016, 0.016, 0.016. So these are the values of width of one fringe. So we need to find the mean or the average value of fringe width. That is, width of one fringe is called as fringe width here. 1, 2, 3, 4, 5, 6. Add all these and divide it by 6. That is 0.0173 plus 0.0173 plus 0.0163 plus 0.016. 3 times I am adding it. I got, that is, the total value of all these is 0.0989 divided by 6. That is because I have 6 values here. 1, 2, 3, 4, 5, 6. Add all these, you will get a value. Divided by 6, I got 0.01648 in centimeters. So this is the mean fringe width value. I repeat it here. After taking the readings, that is MSR VAC of nth fringe, n plus 3, n plus 6, n plus 9, n plus 12, n plus 15, n plus 18, based on the requirement, n plus 21, in that way it can go up to n plus 30 also. And then go for finding out total reading. The calculation for total reading is MSR plus VAC into the least count. The least count of traveling microscope is 0.001 centimeter. And after this, width of 3 fringes are taken by subtracting the adjacent values in a correct way. And then width of one fringe is width of 3 fringes value divided by 3. Then taking the mean of all these 6 values. Add all the 6 divided by 6. If you have 10 values, add all the 10 values. You will get a total value divided by 10. Since I have only 6 values here, so I have divided this with 6. So I got beta as 0.01648 centimeter. Now, in the formula, we have lambda L by 2 beta. Lambda value is provided to you. Beta, just now we have calculated. L is, what is L? The distance between the edge of contact and the specimen wire. Now, during the experimental portion, the vertical cross wire in the eyepiece of the traveling microscope is made to coincide with this edge of contact and the MSR VSE values are taken. Without disturbing the setup, the traveling microscope, the cross wire, especially the cross wire, is moved towards the specimen wire, and the vertical cross wire of the traveling microscope is kept over this specimen wire, and again the MSR and VSE values are taken without disturbing the position of the apparatus. We got this sample readings 8.9018 and 5.706. Same way for total reading, MSR plus VSE into LC. So I get 8.918, 5.706. So the difference between these two is, this is the edge of contact and this is the specimen wire. So this is 8.918 and this is 5.706. This is considered as R1 or R2. The difference between these two will give you the distance between the edge of contact and the wire. So 8.918 minus 5.706. The value is 3.212 centimeters. So I got, that is here L is 3.212 into 10 power minus 2 meters. Now we are moving on to the calculation part. Calculation is, you need to write whatever parameters required for the calculation for finding the thickness of the wire. So what are all the values? First is lambda is provided 5893 into 10 power minus 10 meters. Then beta value is, just now we have calculated 0.01648. 0.01648 into 10 power minus 2 meter, and then L is equal to 3.212 into 10 power minus 2 meter. So when the value is in centimeter, convert that into meters. So now write the formula. T is equal to lambda L by 2 beta. Substitute the value. Lambda is 5893 into 10 power minus 10. L value is 3.212 into 10 power minus 2 divided by 2 into beta 0.01648 into 10 power minus 2. So take your calculator, switch it on, 2 open brackets, and then all the numerator values, close it with a single bracket, and then divided by 1 open bracket, substitute all the denominator values, double close brackets is equal to, will give you a value. Now I am going to use this calculator, that is double bracket 5893 into 10 power minus 10 into 3.212 into 10 power minus 2, close it with a single close bracket, divided by open with a bracket 2 into 0.01648 into 10 power minus 2, double close bracket. I got 5.7428 into 10 power minus 5 meters. So this is the thickness of the given specimen wire. It depends upon the specimen wire's thickness. So the specimen given to me may be a very thin wire of 57 microns, that is micrometers, or express it in this way. So the result is, the thickness of the thin wire is determined given thin wire, thin specimen wire is determined using air wedge method, is determined using air wedge method as T is equal to 5.7428 into 10 power minus 5 meters. Use the calculator properly, you will get the exact value for your readings. Thank you.